Hi everybody. I just wanted to make some quick videos for an answer key for the lesson that we're doing on Friday, January 22nd. I'm going to make a separate video for each problem, and there are 3 problems. All right. Representations of a linear context. This is the answers. Problem number 1. Hillary is saving money for college expenses. She's saving $200 per week from her summer job. Currently, she does not have any money saved. Complete the table and graph to show how much money Hillary will have 6 weeks from now. All right. The table is easier, so we'll start there. She's saving $200 per week, and she doesn't have anything to start with, so we start with 0, and then she's doing 200 per week. 0 to 400, 600, 800, 1,000, 1,000, 1,000, 1,200. And these are all dollars. Okay. So for the graph, the thing about a graph, and this is why I wanted to do it on using digital ink instead of on Desmos, it's because I wanted you guys to practice creating a graph and making sure that you get all the pieces in the right places. Once I'm sure that we know how to do that, then we'll go back to Desmos pretty consistently because it's so nice when Desmos just makes your beautiful graphs for you. But that's okay. We got to do this too. So time in weeks. This is your input. So this is the X. This is your input. Input, which is the same thing as independent. Independent, which is the X that goes on the X-axis. So the X-axis is going to be time in weeks. And I need to go up to 6. So I'm going to make each one 1. So like 1, 2, 3, 4. There's no need to label every one. 5, 6, 7, 8, 9, 10. And I think this is a 15 by 15 grid. 1, 2, 3, 4. Perfect. Okay. So we're not gonna use all of those, but that's okay. And then the other side is the output, which is the dependent variable, which is the Y, and the Y goes on the vertical axis. So this one is going to be amount saved in dollars. And as long as you have the unit written in the label, then you don't need to put the units on your numbers on the graph, which makes things a little cleaner. All right, so going up, I need to go up to 1,200, and there are 15 squares going up. So if I make each square 100, it will fit. So 1, 2, 3, 4. This is $500. 1, 2, 3, 4. This is $1,000. 1, 2, 3, 4. This is $1,500. Okay. And then the next thing I'm going to do, I'm going to make this a little, how big is that? That's perfect. Okay. That might be a little big. Maybe I'll go down one. Go down one size and chunkiness. Okay. So this is my first point, 0, 0. So that's going to go right here at 0, 0. Then my next point is at 1, 200. And then at 2, 400. And then at 3, 600. 4, 800. 5, 1,000. 6, 1,200. Now, because I have space on my graph, I'm actually going to keep going all the way up. And then a graph, I actually want, I want an arrow on it. Okay, and we'll do it, maybe not quite so. Okay. So when I do a graph, what happened there? Okay. Perfect. Oh. Okay. You could do your graph using the straight line tool. You could sketch it either way, but it should be a straight line going through those points. And the more accurate you can draw your graph, the more useful your graph is going to be. All right. Write an equation for the amount of money Hillary will have saved after W weeks if she continues saving at the same rate. Okay. So here, this curriculum wants you to use M and W. I don't know that I really care. And the money saved, we've called that Y. And the amount of time, we called that X. So you could say she saves $200 every week. So you could say M equals 200 times W, or you could say Y equals 200 times X. Both of those are the same. You just have to define, like, Y represents the amount of money saved and X represents the number of weeks. Is the context linear? Yes. Use evidence from the context graph table and equation to support your answer. She's saving the same amount every week. So the rate of change is a constant number. We haven't really looked at relationships that have a changing rate of change, but only linear relationships are adding the same amount every time. Nonlinear relationships, the thing that makes them nonlinear is that the rate of change is not a whole number, or not a single value. It's not constant. So, yep, it is linear. And you can see that, like, the line's a straight line. This is going up by the same 200 every time. Straight line, all that stuff. Okay, cool.